Homework 13, section 7.1, the standard normal curve, video 8. This should be the final video in this section. In the previous 3 videos, we looked at how to find the area to the left of a z-score, how to find the area to the right of a z-score, and how to find the area between 2 z-scores. To summarize them, to find the area to the left, just look up the area in the ZTable. To find the area to the right, look up the left area in the Z-table and subtract it from 1. And to find the area between 2 z's, look up both of their left areas and subtract them. But in future sections, we'll be in situations where we have to do the reverse, where we already have a picture with a specific area and we need to find the z that cuts that area off. For example, find the z-score that has an area of 2.5% to the left of it. In terms of probability, we're attempting to answer this question. Actually, let's draw the picture first. Sometimes the visual does it all. If we were to draw the bell curve, 0 in the middle because we're still talking z-scores, we want to find a z that has an area of 2.5% to the left of it. So z equals something, and we want this area to be 2.5%. Now, because the areas in the z-table are in decimals, not in percents, it would be better to convert 2.5% to a decimal by moving the decimal 2 places to the left. So the area is 0.025, and more specifically the left area. As a probability question, we already know the answer to it, 0.025. What we don't know is the number that we want z to be less than. So it's reversed there also. We have the answer, but what was the question? Kind of like statistical jeopardy. So how do we do the problem in reverse? The answer is we use the chart in reverse. Just remember that the numbers inside the chart represent left areas. The numbers along the edges tell you how to find the z. So when you're doing a reverse z problem, you do the chart in reverse. Find the area and then the z that is associated with it. Now keep in mind that, and I didn't point this out specifically, but you saw it in the previous examples, in the z-chart, all the areas have 4 decimal places, and since this area only has 3 decimal places, we're going to append a 4th decimal place of 0 on it. And now we're going to use the chart, or use the table. Table, chart, same thing. But this time we're going to go digging on the inside of it to find the area, and then go outwards to find the z associated with it. So let's take a look at our chart. Now, one important thing to realize about the z-chart is that, okay, before we answer that, I need to point out that there are limits to the z-chart. If you're less than -3.7, you just say an answer of 0.001. And on the other end, if your z is 3.7 or greater, you just say 0.9999. But I digress. It's important to notice how the areas are structured in the z-chart. It's kind of hard to see here because a lot of these areas are the same to 4 decimal places. So let's scroll down a little bit more. On the negative side of the chart, the areas are increasing from right to left, and they keep increasing as you go down. On the positive side of the chart, the areas are increasing from left to right and keep increasing as you go down. So it's like you're reading a book, except on the first page, you're reading the sentences backwards. So we need to find 0.0250. What I would do is I would look in the first column until you get close. Okay, we're in the right neighborhood, and then I would just start scanning across. And there it is, right there. It's my other finger. 0.0250 is the exact left area that we're looking for. So what's the z-score for this left area? -1.9. Okay, it's off the chart. Now if this happens on your computer screen, you can just count it. Just remember the first column is 0. So we're looking right here. Let me use the pointer. All right, where are you, mouse? There you are. All right, can y'all see the cursor right there? Right here. Let me highlight so you can see it just real quick. It's hard to do this. There it is right there. See? Oh. Well, that's not what I wanted to happen. Okay, so we were in the negative 1.96 row, which is down here. And let's just go across, start counting with 0. 0, 1, 2, 3, 4, 5, 6. And if we did scroll up this column, you would see that it's a 6. So the z-score that we're looking for is negative 1.96. A bit more. Negative 1.96. And again, there will be problems in the future where we have to do the z-table backwards, where we start with the area and locate the z-score that cuts off that area. What about the second example? Excuse me. Pardon me. What z-score cuts off 2% in the right tail? Well, we got to be careful because our z-table tells us left tail areas, not right tail areas. But you should still draw a picture. You should always draw a picture when you're using the z-table. 0 in the middle. This time we want 2% in the right tail. So we want this area to be 2%, but as a decimal, move the decimal to the left 2 places, 0.02. But because the areas in the z-table have 4 decimal places, append 2 zeros on it. And the question is, what is this z? The corresponding probability question would be the probability that z is greater than what, because it's to the right, is equal to 0.02. So, how are we going to find that z when our table tells us left areas and this is a right area? Well, we're going to kind of do the same thing we did before. Not a subtraction problem, but take advantage of the left area. Because the right area, and I should have written the word right there, because the right area is 0.0200, that tells us that the left area is equal to 1 minus 0.0200, which is equal to 0.0800. So this is what we would look up in our table. So let's go back and look up 0.0800 in the table, and we'll find our z-score. Just remember, the numbers in the middle are areas. The numbers on the edges are the z's. All right, these are all pretty small, so we need to go... By the way, it should be obvious that the z is positive because it's to the right of 0. So let's go to the positive z-score chart. And we're looking for 0.0800. Is that right? No. Whoa, 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 whoa. Back that train up. I'm sure some of you were probably yelling at me a minute ago. I have not made a subtraction error this egregious since I don't know when. But 1 minus 0.0200 isn't 0.0800. Think of it in terms of percents. If this is 2% of the area, then the left is 98% of it. This decimal should be 0.9800. Oh my gosh. I'm not going to refilm the video just to remove that error so it'll live forever on YouTube. But it does point out that it doesn't matter how good you are, it is easy to make a casual mistake, especially when you're a little arrogant sometimes. All right, so let's go back to what we were attempting to do. I'm glad I caught that, which was to find the area, and this time the area is 0.9800. If you notice in this 1.3 row, the areas are still too small, still too small, still too small, still too small. We're getting there, and we're almost there. We're almost there, and wait a minute. look in the 2.0 row, the 2.0 row. 0.9798, 0.9803. It skips right over the number we're looking for. We are looking for 0.9800. This actually happens more often than not when you're looking for an area and it is not in the Z-chart. The other one was, and I knew it was going to be. So what do you do when the area you are looking for is not in the Z-chart? The answer is you choose the area that's closest to it. So which area is closer to 0.9800? 0.9798 or 0.9803? It's pretty close, but the one on the left is closer by the slimmest of margins. The way you can tell that is to do a little subtraction. And this time I hope I do it correctly. In our table, we found 0.9798 and we found 0.9803. I believe it was in the 2.0 row, and the number that we're looking for is between those two. How can you tell which one is closer? Well, ignore all the decimals for a second. 9,800 is 3 away from this, but it's only 2 away from that. So if you think about how far apart the number you're looking for is from the numbers that it's in between, whichever one has the smaller difference is the one that's closer. So we're going to use this area to look up our Z-score. Now it does raise the question, what happens if it is dead center? Because there are some examples where the area you are looking for is the same distance from both. There are a variety of ways to handle that, but until further notice, what I always recommend is defaulting to the larger decimal up top. So in other words, if the area you're looking for is dead center between two areas in the Z-chart, then go to the one on the right. Otherwise, choose the one that's closer, and the one that's closer in this case is 0.9798. So we're going to use that area, and I believe it was in the 2.0 row. Here it is. That area, 0.9798, is the closest one in the chart to 0.9800. So the Z we are looking for is 2.0, I believe that's 5, but let's scroll up just to make sure. 2.0, come on, page up. Oh, stupid computer. Do I want to turn on sticky keys? I don't even know what sticky keys is. 2.0, I'm pretty sure it's 5. Let's just page up. Okay, the cursor must be parked somewhere, not allowing me to do any scrolling, but I'm gonna do it until it works. So we're in the 2.0 row, and we are in the 5 column. We could have also counted it from the left by counting starting with 0, 2.0, 0, 1, 2, 3, 4, and 5. So however you slice it, it's 2.05. Focus. Thank you. 2.05. As far as reverse engineering between problems, it's impossible unless the areas on both sides are the same, in which case it's easy to do. But I'll leave it up to you to hash that out. It's not as bad as it seems. All right, so that wraps up the videos for this homework. I want to emphasize that being able to use the Z-chart it's not only just a good idea, it is essential to succeeding as we move forward. In fact, if you can't use the Z-chart, you will not only fail the next test, but you will fail it miserably. It is that important. So please, get to this homework, practice using the Z-chart, and let me know if you have any questions.